Can you hear me? Okay. So, good afternoon, everybody. I'm Gianni Rosa Gallina, and we'll talk about Xamarin and cross-platform app development. How many of you already know a little bit about Xamarin? Have heard about it? Ever used it? For those who heard? Okay, so this will be an introductory course, a lecture, let's say, with an overview about the tools and what is Xamarin. And then we'll see a little simple application that implements, that uses Xamarin to build an app that runs built with the same source code on Android, on Windows, and on iOS. And we'll see how to build that using the Microsoft tools and the best design patterns that, similarly to the session before ours was talking about, if you were there. And we'll see the best patterns to use to share the code and use almost up to 95% of the same code on the three platforms. Does anybody know .NET, apart from Xamarin? Okay, so we can go. I'm a software engineer in the augmented reality and virtual reality field, and a consultant on many topics, and one of them is cross-platform app development. We'll see why there is the need to develop cross-platform applications, which are the current approaches to do that, and then why .NET and Xamarin is a good option if you want to enter the cross-platform app development. And then, as said, we see architectures and design patterns to implement the most code sharing as possible. So, why cross-platform development? Since a few years, there is a paradigm shift in the business application development. We are moving from client-server architecture towards mobile plus backend. So our application usually have a backend counterpart on the cloud or on premises service, and an app that runs on a user device. This because company wants to let their users have the most from their preferred device. Somebody prefer iOS devices, somebody prefer Android, others prefer Windows. And they want the same UI and possibly the same behavior on all the three devices. Okay. Also, users or customers pretend and expect the same user experience across the application. If they are used to Android, they expect that the Android version of an application behaves like other Android applications. The counterpart is iOS application behaves like iOS applications. And that's a big problem for developers who has to keep in mind that Android has some design patterns, iOS others, and Windows, of course, different ones. And this change is expensive. We use different tools, we need a different team of people and different knowledge. More platform means more opportunities instead. Users want the same app on different devices, and developers want to create and deploy their apps to reach the most user base as possible. So, how can we obtain that? There are two main current approaches. One is the web hybrid technologies, and the other one is native platforms. The web hybrid technologies substantially means that we develop with HTML5, CSS or JavaScript, and use some frameworks like PhoneGap, Cordova, Ionic plus AngularJS, or NativeScript. The pros of these hybrid applications is that we have the full source code sharing, either on mobile and on web. We have an independence on the device, so we develop once and it runs on three platforms. We have the same user experience across the different platforms. We use the same development environment, so if we know JavaScript and their tools, we can continue to use the same tools to develop mobile applications. And it's easy to do the app management and deploy, because we just deploy a website and the applications that run on different platforms becomes instantly updated without passing through app stores reviews. The cost of this approach is that we have less performance than native applications. Applications that run on web containers have no access or limited access to specific device features. And also, we have not an optimal debug experience. It depends on the tool you use, but it's suboptimal. On the counterpart, we have native applications development. So we have a Windows stack, an iOS stack, and Android stack. On Windows, we can use C#, .NET, C++. On Android, we can use Java or C++ or other languages. And on iOS, we have Objective-C, Swift, or C++. The pros of this native application approach that we have full native user experience, we have full access to the platform API, and we have native performance. The problems here that if we develop a native application for each of these platforms, we have limited source sharing, source code sharing, and at the same time, we need to develop 3 times the same application. The problem and the risk of this is that maybe one of the 3 platforms becomes dominant, as happening, and for each platform, we need different IDs and tools. This means that we have different teams that develop the application, different teams that design the application, different teams that maybe publish the application or handle bugs or different stuff. Also, in this case, we have suboptimal debug experience because for each application we may have different bugs, and when we fix the bugs in for one platform, it's not necessarily the same bug that we have on other platforms. So we have triplicated the costs and efforts to support the different platforms. As I was saying, there are different development tools. So for Windows, we use .NET compilers and Visual Studio. On Java, on Android, we have Java, Java Virtual Machine, and Android Studio or Eclipse. And for Apple, we have Xcode, and of course, we need a macOS system. So why .NET and Xamarin? We can direct our efforts to both 3 platforms with one language and one toolset, which can give us almost native API and performance, almost native UI experience and performance, and if you want, a single UI framework. So you can share also the user interface code. In addition to the tools thanks to Visual Studio that runs on different systems, we also source control backend support, common build systems, common testing frameworks, and common monitoring tools. But let's go through these topics one by one. So let's start from the one language, one toolset. .NET and Xamarin, leverages .NET through Mono. Xamarin has been acquired by Microsoft last year, and now it's free to develop with it if you have Visual Studio, also the Visual Studio Community Edition. Thanks to Mono and thanks to .NET, we can share the same code for the application logic. And through various ways we see later, we can share for each platform, and then if you want, we can obtain different UIs, always developed with C#, either for Windows, either for phone, for Android, or for iOS. But the most important thing that we have 100% of the native API available. What you can do in Android Studio, what you can do in Xcode, you can do as well in Visual Studio. There's an interesting stuff like this because each time a new feature, a new version of each development platform, Xamarin is updated the same day it is available for native developers. So since the first day, you have all the tools and libraries available for your application developed in .NET and Xamarin. The tooling. If you have a Windows machine, you can use Visual Studio 2015 Update 3 with Xamarin, which is built in, or Visual Studio 2017, which is just became out last month. On Mac, you have the Xamarin Studio, or Visual Studio for Mac, which is currently in preview, but it's the same version of Visual Studio that runs on Windows and can share all the logic, all the application, all the projects. When you install Visual Studio, also the free edition, the community edition, you have the option to install the third-party tools for Xamarin. So on the left, you can see a little bit, but you can choose to pick the Xamarin components for Visual Studio 2015. On the right, the new setup for Visual Studio 17, which includes the Xamarin tools. And the interesting thing from Microsoft is that every time Visual Studio runs, it checks for an updated version for either Xamarin tools, Android tools, or Xcode tools, and automatically updates the system if you want to be up to date to the latest version available. Visual Studio for Mac is new, as it was announced last year in some events from Microsoft, and let you develop application for iOS, Android on Mac with either C# or F# and Xamarin. It also supports web development, and you can edit, compile, debug, deploy projects the same way you do on Windows. And it's fully compatible with the Visual Studio for Windows, so if you have teams which prefer Mac instead of Windows machine, they can share both the same projects and everything works. The unique limitation of this approach is anyway, if you want to build iOS application with Xamarin, you need an Apple machine with a macOS installed, because for licensing issue and components inside the Apple build system, we need an Apple to build iOS application. Apart from that, you can use Visual Studio and forget if you have two machines, one for Windows and one for and one Mac, you can do all the developments on Visual Studio for Windows, and you have to install a little agent on the Mac OS, which talks to Visual Studio remotely and build the application through the Visual Studio interface. But let's go on and see why and how we can reach the native API and native performance. We can obtain native performance because when we use Xamarin for Android or Xamarin for iOS, the code in C# and .NET becomes compiled down to the native format. So on iOS, when we compile the C# code, we obtain a full Apple binary, which runs natively on the iOS platform. On the same way, Xamarin for Android runs directly the .NET CLR in Android, so the code is .NET and runs, and at runtime it becomes Java with the just-in-time compilation. So for Windows, that's a little bit easy because we have already .NET in the system, and when we compile application for Windows, .NET becomes and remains .NET, and we have a native compilation. We have the appix package, and then we can build the ARM, x86, x64 binaries and upload to the store. For iOS, from the .NET C# we obtain ahead of time compilation, so we obtain a native ARM binary. And for Android, I was saying, we can compile and link directly the .NET CLR code. We obtain an APK which contains the mono runtime, and then at runtime, the mono runtime compiles in Java bytecode. Since Visual Studio 2015, Xamarin for Android enables also to use C++ native code. So if we have third-party components, or we need very optimized code to run, for instance, for graphics processing or 3D libraries, we can build it in C++ and use from our Xamarin code. What can we do with Xamarin to access the platforms? These are standard .NET packages and namespaces. So if you know .NET, or you already familiar with these names. Anyway, this is the components that let you access the system at low level. So with Xamarin, we have all these components ported to the three platforms. For Windows, we add all the stuff from Windows Phone and Windows Universal App Application from Xamarin. For iOS, we have access to the map kit, UI kit, core graphics directly. We write C# code, but use these components as they were C# objects. And for Android, we have a similar approach. So we can access to the text-to-speech components, the render script, NFSC, and many, many others libraries. So you write C# code with objects that are C#, and then they are translated back to native components behind when the application runs. This way we can obtain native performance, because effectively, apart from writing C# and .NET, everything then is translated to native components and runs as they were written in Java or Swift or Objective-C. The same applies to the UI. In Visual Studio, we have the app designer for iOS and the app designer for Android. So we have all the graphic components here. We can just drag and drop and design our UI, either for iOS or for Android, and of course for Windows. But in this way, we are not sharing the UI. We can share all the application logic, but we have three different UIs with the three different styles and components. So, Xamarin had the single UI framework. There is the Xamarin Forms framework that substantially gives us one code for the UI, and it translates back natively to iOS, Android, and remains the same on Windows. So we declaratively design our interfaces. We have components for our interfaces which abstract the specific platform, and then behind the scene, Xamarin Forms translate that to labels and buttons with the appropriate style for each platform. But let's see a little demo. So, this is Visual Studio. On the right side, there is the project. Can you see? Anybody can see that behind? Otherwise, I can zoom in. Let's try this way. Okay, so our solution contains three main components, which are the three versions of the application. One targets Android, one targets iOS, and one targets Universal Windows, which means Windows Desktop or Windows Phone. The other components in the portable part, core view models, are the shared code, so the business logic of our application. And these are unique. I mean, here we have just one library for each of the three platforms, another library for each of the three platforms, and also for the UI, we have one library shared across the platforms. Let's run it so you can see which application, how the application runs and what does. Here you have an Android emulator. So I just build the application and it will deploy it on the Android emulator. If we can do it. Okay. Probably in this demo we are using the emulator just for the sake of simplicity. Otherwise you can plug your phone and use ADB as you were on Android Studio, and you can deploy directly on your phone or your device. Also, it happens the same with iOS, and also the same with Windows. So the deployment started, now it's running the application here. And we have the Windows counterpart. So we have the same application running either natively on Windows and on Android. I cannot show you the iOS version because here I have not an Apple and an iPhone. Anyway, as you can see, there are two applications. with identical interfaces that share the same logic and the same UI. What does this application do? It has a cloud backend on Azure, which substantially has a photo list. So I can download some photos here, if the network assists. And I can have photos here. They have a common local DB based on SQLite, both on Windows and on Android. And on the cloud backend, we have a few REST API that Azure can give you for free in the standard plan, which enables you with no code writing, more or less, to obtain a full database on the cloud and automatic syncing of the local database on the device. Of course, the network doesn't help. The idea is to have some photos here and some photos there. They are the same database. And then I can access the camera on the device and take a photo. Currently, the emulator doesn't work with my webcam, so this is just the emulated camera. I can take a picture, accept it, and it gets uploaded on the cloud. I just have to put a name here. Test. It has been uploaded, and then I can obtain it from Windows. Once it syncs. The help of the network doesn't show up anyway. You should see both here and there. You should see the same photo, but it's not showing up. Anyway, I can do the same thing with the Windows application. I can take a photo. Now it takes me from the built-in camera. And then it stores locally on the device in photo VP, and you can upload it. And in a minute, I'll show you all the code which is shared across the platforms. So I just can write it once, and it runs on Android and on Windows. So here we have the photo, but we lost the Android version. So as you can see, the database is common. I use the Windows version to upload the photo to Azure, and the Android application got it. But we can do also this one. Anyway, it should work. The network doesn't help. So, how we can obtain this? Let's go back to the slides. What we have to keep in mind to develop a cross-platform application with Xamarin. The first thing, we have to think about the backend. We want to share between platforms, so probably we have to think to the backend. And thanks to either Google or Microsoft for the cloud offers, we can build Web API, REST API that both platforms can call using standard HTTP clients. Then we have to choose between hybrid, plain native, or Xamarin. Uh, it depends on your team, it depends on the application, it depends on the cost you want to support for the coming months after you deliver the application. Because if your team is already web-oriented, everybody knows JavaScript, and the application doesn't require so much performance, you can try to build hybrid applications because you have common tools already in the power of your developers. You already have the possibility to deploy once and run everywhere, but it depends on the application if it's the right way. Because if the application is graphics oriented, probably it's not the best way. But if it's a business application or a line of business application, maybe the users of a hybrid application don't even can see the differences between a native application or a hybrid one. Plain native, it depends if you have the team available to build 3 applications or 2 applications, depends Android or iOS. So you have the tools for Android, the tools for Mac, the tools for designing the interfaces for both platforms, and the people to maintain 2 applications. So once you build a native application, you need to take care of the cost involved in designing the application for 2 platforms, to build the application for 2 platforms, and then to maintain 2 platforms separately, because iOS has its own code base and Android has its own code base. If your team or your people knows .NET, Xamarin may be an option, because you can obtain the best from the hybrid, because you really write once and then run on every platform. And then you have also almost native application, because as we've seen, JavaScript, .NET becomes Java on Android and becomes a binaries ARM on Android, on iOS. And then we have some patterns to adopt. One is MVVM. Who knows MVVM? Okay, for those who don't know, MVVM is similar to MVC pattern for the user interface. It's a pattern defined and built from Microsoft when they defined the first version of WPF framework for the user interface. And you have some options to use compatible with Xamarin. MVVM Cross or MVVM Lite are the 2 most famous libraries for MVVM. Otherwise, you have Code on FX, which is a new one in a few weeks. Then you can decide between shared libraries or PCL. The difference from the 2 is simple. Shared libraries in Visual Studio are files that are shared with the main application. So, as we've seen before, in Visual Studio, when it's load, I have 3 applications here, and then zoom in a little bit. I have 3 applications there, which are Droid, iOS, and UWP, and then I have 2 projects for the UI. One is the portable version, which is PCL, as was saying, and the other one is a shared. The difference between the 2 is that the shared project is just a copy of the file that gets linked to the main application, either Droid, either iOS, or Droid UWP. So you don't have a different DLL library, external library for this project, but the files are copied inside each project at compile time and built together with the application, either for Android, either for iOS, or either for Windows. Different from the portable version. The portable version is a separate assembly, a separate DLL, a separate library, which is built for each platform, but use a reduced version, a common version of the framework. So, if I build for a portable library, I build against a .NET framework or a Mono Droid, Mono iOS framework that is shared between the 3 platforms. So I'm sure that with the class that exists in my portable library can run as is for iOS, for Android, or for Windows. And I don't have to use differentiation inside the compiler, different defines to disable or enable codes depending on the application. This way, I can deploy a single version for each common stuff. So I have the UI using Xamarin Forms, I have the business logic in the core, and the view models in the pattern model view model in another library. But they are just 3 projects that are linked together the main application, but they're the same DLL. I build once the DLL, and then during the build process, they are linked to the native version of the application. If something is not clear, just stop me and ask. So let's go back to the slides. In addition to sharing the code using PCL or shared libraries, we can also use native libraries. So if I need something from third party that is only available for Android, and they give me a native library, a DLL or a SO Android library, I can use it from C#. I need to build some bindings, as it's called in .NET jargon, and then I can use the object exposed by the library inside my C# application. And if I need some platform-specific stuff, I can build it natively. So if I need a US component, I can build it in native language using Swift. And then through the bindings, I can link it to my application and make it available for my common code base. If I develop the same components using the native approach, either for Android, either for iOS, and for Windows, I have one common code base for the logic and one common UI, which once built differentiates on each platform. Or otherwise, I can use Xamarin Forms, which already did it for us. So we have lots of components for the UI, and if we need something else and want to build it manually, we can use UI controls from third-party vendors like Tailoring, Infragestic, or Syncfusion, which are the most famous, which let us to use the same component at sharing code base, and it renders natively on each different platform. I was showing you the architecture in Visual Studio, but as the diagram, but a little bit try to explain what we've seen. So we have portable models and code services, which means we have the same code, business code, shared across the 3 platforms. We have portable view models, which delivers our UI and drives our UI. So in the MVC pattern, we have the controller. The view model means that it's the same function as the controller in MVC. And then we have the portable UI based on Xamarin Forms, and a little bit stuff on the Android UWP iOS little project, which is just for the platform-specific part of starting the application, configuring it, define the icons and stuff like that, which is different for each platform, of course. But you can, through Visual Studio, define all the stuff inside Visual Studio, and the builders automatically arrange the stuff for you. Just for a little bit explanation, but if you need more info, just ask. We have built-in Xamarin Forms possibility to have object repository and dependency inversion IOC components. We have the command class, which is an abstraction to the user interface interaction. So when we have an event in the user interface, that event, to be abstracted away from the UI code, is translated in a command. If we have a button which clicks, the click button is associated to a command that runs in the view models controller, and it is a common shared library. Then we have models, which are our entities, our domain-specific objects. And then we have services of business logic, and it depends on the application, but we can share it through the 3 platforms. As I was saying, the view models abstract away the view, so we have potentially the same UI for the 3 platforms, or 3 different UIs for the 3 platforms, but our view models is the same, and we can share the same logic, so we can hide a label or handle the click button in the same way indifferently of each platform. I was saying there's this difference between the shared and portable class libraries. So you must be aware that the shared project is just a copy of the file built together, the platform-specific application. So if you need to differentiate you need to insert some defines that check on which platform you are building for, and then disable and enable code specific for that platform. Or alternatively, you can use the portable class library, which is something that Microsoft already prepared for us, and then guarantees us that if we build for the portable class library, it will run indifferently either on iOS, Android, or Windows. And if we need to use something specific from the platform, we can use the inversion of control and inject our native services, platform-specific services, in the application, in the common code. From the point of view of the cloud services, we, as saying, we can use the Azure storage or the Google storage or the Amazon. It doesn't matter. The important thing is that our application can access them through REST API, so we can share the same logic also in the code base. And then if our cross-platform code is not enough, as I was saying, we can write native code and link it to our application through Java bindings or C++, and then translate it in C# bindings and use it from our code. We can build custom controls, we can build custom renderers, and then we have native control in Xamarin Forms. So just quickly, we can see the code that runs the application. As I was saying, this is the UI project which share from Droid iOS UVP. We have 3 pages, with the one I showed you before. We have the first page, which is the photo list, another page, which is an upload photo. But if we open it, substantially, we have the same code. This is the XAML, which is the language that Microsoft defined for defining WPF applications, and it extended and ported to Xamarin in a different version. And the target is to unify the same XAML for all across Xamarin, UVP application, and WPF application. Currently, you have to write it down manually, but this code then is translated back to native Android components, to native iOS components, to native WPF component. And from the point of view of the code, we have some services here. For instance, we have the Azure service, which substantially has an HTTP client, which, when called from the click button, substantially receives the photos, but it doesn't know anything about the UI. And when we click on the Take Picture button, it gets the photo from the native camera object, either on Windows or Android, converts it in byte array, and sends it back to the Azure service for sharing in the database, in the common database. And we obtain this stuff thanks to the interfaces. We have some interfaces that define our application, our components, and each component then has an implementation here, which, thanks to Xamarin Forms, is automatically injected when needed by the dependency framework built in Xamarin Forms. So we don't need an inject or other IOC container. If we use Xamarin Forms, we already have it out of the box. Other stuff we have is the fact that I can use native components. As I say, the camera control, I can see it anywhere here because it's an object that gives me Xamarin from built-in. So I have directly the photo service, the camera page view model. I can have it thanks to here. This line here, which just asks to the system cross-media current pick photo sync, will open on Windows the camera service to take a picture. On Android, it will open the camera application to take a picture. And on iOS, it will open the camera application to take the picture. And then we'll retrieve back our byte array and then send it back to to Azure to save it. But we just, with one line of code and nothing else, thanks to Xamarin Forms, or Xamarin in general, if you want, you don't need to use Xamarin Forms to take a picture this way. This is Xamarin has without any UI reference. So I can use shared objects. Xamarin already developed for us common components. We can use them as is to obtain the cross-platform compatibility. Okay. We are almost finished. If you need more information, there are plenty of documentation on either on visualstudio.com or Xamarin platform website. There is the Xamarin University Initiative, which is a series of courses and tutorials to get starting with Xamarin development for different platforms, and then blogs on Microsoft MSDN to obtain references and more information. I want to just one more thing, that is the Xamarin Alliance, which is a new initiative started a few weeks ago by Microsoft. Substantially, it's a multi-challenge experience for developers. If you want to learn about Xamarin, develop application, and earn a sort of certification of Xamarin diploma, which states that you know a little bit of Xamarin and how to develop a cross-platform application with Xamarin, you can go through the challenges, and at the end you will find, will obtain the certificate. And this prepares you to do the Xamarin certification exam if you want. This is not the exam, but if you go through all the challenge, you know almost all the topics that at the exam certification will test. There are more resources about Xamarin also in the Xamarin Alliance. And if you have some, we have some minutes, I think. 2 minutes.